Time to learn the Imperial Rule. You're way too close to that camera.
So taking a look at a normal distribution and the empirical rule. So if we take a curve, right, we're just going to look at a distribution of data. So if you take a curve or take a bunch of data, what you tend to find is it tends to gather around in the center. So for example, I'm going to do this with IQ as my example, right? We can say that the average IQ or the mean IQ is 100, right? Just from studies. So this symbol here is just the symbol for mean or for average. And the standard deviation is 15, right? In this example. So what just briefly, mean just means the average. So most of our numbers are obviously going to cluster around 100. So if we take this to be our mean, 100, then there's less people up at the high end who might have high IQs of 150 or 145, whatever else. And then there's less people down at the low end that have very low IQs. Most people tend to have an IQ in and around 100, right? So this whole normal distribution and empirical rule is going to be this idea of where most of people lie and yada, yada, yada. Just very briefly on standard deviation, okay? Just to get the idea, standard deviation is just a measure of the variance from the mean or how spread out the data is. So if I just give you two examples here, something with a large standard deviation would be something like this, where if we take the center again to be the mean, there is a large kind of spread in the data from the mean either side. If I take another example, this guy here has a much smaller spread in the data. So this would have a much smaller standard deviation than this guy. Okay. That's all that basically standard deviation is telling you, just in simplified terms. So back to our original example with the IQ. So I have an IQ test here, and basically what I got was the mean is 100 for this population and the standard deviation is 15. So what we're going to do is we're going to count up one standard deviation up from the mean. So if this is the mean, then going up one would be 115. So adding on 15, 130, and 145. Going back, I'm going to go back 3 standard deviations as well. And this is just a sketch. Obviously I haven't drawn this with a ruler or anything like that. And this guy goes back to 55. So what I've got here is the mean in the center. This is the mean plus a standard deviation. So plus sigma, that's the symbol. This is the mean plus 2 sigma. And this is the mean plus 3 sigma. Going the other way, it would be the mean minus standard deviation, the mean minus 2 standard deviation, and the mean minus 3 standard deviation. And just putting some numbers on that, that's basically saying 100 minus 3 standard deviations, so that'd be 15 by 3, which is 45. 100 minus 45 would give me to 55. So that's kind of just our setup. And any question we go into, we might have to do this, we might have to draw this little sketch and get the numbers. But what's this telling us? So this brings us then to our empirical rules or empirical rules. So what this is that if you are plus or minus, so if it's the mean plus or minus a standard deviation corresponds to 68% of the population. So one standard deviation up would be to here and one back would be to here. This, I know I haven't drawn it quite symmetrical, but this should be perfectly symmetrical. And what we're saying is this whole region here, I'll just shade it in nicely. This is going to be 68% of the population. So 68% of people have an IQ between 85 and 115. Then the next empirical rule is if we go plus or minus 2 standard deviations away from the mean, and that accounts for 95% of the population. So what we're saying here is go from the mean, go 2 across. So I'll do this with slightly thicker dotted lines. So slightly thicker dotted line, 2 across either way. And now we're saying that this whole region, so I'll get just to do it thicker, you can see the whole way through. This now is 95% of people. So we're saying 95% of people have an IQ between 70 and 130. And then finally, the third rule is if you go 3 standard deviations away, 99.7%. So 3 standard deviations away would be going for all the way out here. I'll just do it as a solid block line to a solid block line. And that would be saying everywhere, whoosh, shading all of this in, from beginning to end, all of this shaded region now would be 99.7% of people. So we're saying 99.7% of the population have an IQ of between 55 and 145. Now, just this diagram already looks like garbage, so I'm going to draw you one that I think is much more handy for the exam. But just have a look, where is that last 0.3%? Well, this region out here is 0.15%, and this region out here is also 0.15%, which would give you the 0.3% missing. So a very, very, very tiny percent of the population would have an IQ higher than 145, and similarly, a very, very, very small percent of the population would have an IQ less than 55. Right, so what's the best way to kind of learn this for the exam? Well, I'm going to sketch another one and I'll talk through it then. Okay, so my advice, by the way, to get good at this is to actually sketch it for a bit, just a couple of times to get the feel of it. So basically, if we know between the first one standard deviation away each side of the mean should be 68%. So I'm saying that this region from here to here is 68%. So that's the rule as we learn it in the textbooks, right? But what I find easier is if you just break this into two separate regions. So if it's 68%, that means this region here is 34%, and this region here is 34%. We're going to do the same trend for the next two. So we're going to go 2 standard deviations away. And we know that 2 standard deviations away should be, I'm just going to get this or eyeball this, should be 95%. So I want to work out what this region and this region are. Now you can memorize these numbers or you can just plug in your calculator and find out. I'm going to say 95, take away the 2 34s, or take away 68, gives me 27, and I divide that by 2 because there's 2 regions. So each of these regions is 13.5%. Now, last one's going out to the 3rd standard deviation, out here. So stretching either way, the whole way across. And that is 99.7%. So that's 99.7% up there. So now, what would that leave with our tiny regions out here? Well, just to make this a bit quicker in the maths, I can say 100 minus all these 4 numbers in here. So minus 34 minus 34 minus 13.5 minus 13.5 leaves me with 5. Now, that's 5% for all out here. You might remember the last one, I said that this already was 0.15%, as was this little region out here, 0.15%. So I'm going to take away those 2 regions as well, leaving me 4.7, and I'm going to divide that by 2 to split it. So this guy in here is 2.35%, and this is 2.35%. Okay, now this table here, I would take a screenshot of this, or I'd redraw this, I'd throw this on a flashcard. Do you know what I mean? This is the thing that you want to learn. If you have this, you're equipped to handle any empirical rule question. And just to stress, this is for the empirical rule, right? If it's Z values or something a bit more, then you're not going to use this at all. It's just when the examiner mentions empirical rule or gives, if it just says between 1 or 2 standard deviations away. So all you have to do is learn this and then apply it to a question. So let's take a look at a question based on this IQ example that I gave before. Okay, so taking a look at this example 1 here that I've made. So we've got here a large group of people took an IQ test. The scores were normally distributed with a mean of 100 and a standard deviation of 15. So usually the examiner might give you these in the question, so just have a look out for them, make a note of them. Use the empirical rules to answer parts A, B, and so on. So what percentage of people had scores between 85 and 115? What percentage of people had scores between 70 and 115? And then the top 2.5% scores were let into the Mensa organization. What was the lowest IQ score that was needed to get this grade? So we'll take a look at these 3 parts. Okay, so let's have a go at drawing the curve for this question. So we're going to draw the curve. Don't worry about it not being perfect. There's 100. And we're going to go up and down 15. So I already did this kind of earlier in the example, but I'm just going to do it again. So we're just counting up 15 each time, just 3 standard deviations, and back 15. Now, you might find in the exam that sometimes he cuts the curve off right here, like he makes it look like it touches this point. You just need to know that actually it continues on forever in each direction. but only as far as 3 is what you need to worry about. Now, next that I've done that, what I would do is I wouldn't even read the question yet. I would just take a moment to block out my different areas and mark them. And like I said, these areas out here might not appear, so you'll just need to be aware to add them. So this is my 34%. These guys are 13.5. This is 2.35 and 0.15. And same over here, 2.35, 0.15. Once I've marked that, I go back to the question. So the first question said, what percentage of people had scores between 85 and 115? So between 85 and 115, well, that's going to be quite nice. So part 1, between 85 to 115 is just these two, 34 plus 34%, which is my 68%, or 1 standard deviation away. That's it. Part 2 then. What percentage of people had scores between 70 and 115? So between 70 and 115, so I'm going from this region here all the way to here, I'm going to say it's 13.5 plus 34, oopsie, plus another 34. So it ends up being 81.5. From 70 to 115, that's going to be 13.5 plus 34 plus 34, which is 81.5%. So far, so nice. Part 3 said the top 2.5% of scores were let into the Mensa organization. What was the lowest IQ score needed to get this grade? So we just need to find where the top 2% of people are. So just take a look. It's not clear. There's nowhere here that says 2.5%. But if we take a look at these last two regions, if I take 2.35 and I add on the 0.15, we'll notice that gives me 2.5%. So these two regions together, let's get a little color to highlight it. These two regions add up to be 2.5%. So anyone who got above 130 here was let into Mensa. These are the top 2.5%. So what's the lowest score that you could get? Well, we're going to say the lowest score is 130. 130 is the lowest score. And that's it for the first example. Okay, so taking a look at example 2. So in this case, a principal normally distributed a school's maths grades for the year and found that 68% of the student body scored between 45 and 65 points. So normally distributed, so there's your big hint to use this curve once again. And he tells you 68% of it. So he hasn't let in the same way as last time. And actually his first question is, what was the mean and standard deviation of the year group? Okay, now we'll just take a look at the rest of the questions. Use the empirical rule to answer the following parts. Great, so we do need to draw this curve, figure out the mean, the standard deviations, and then use the rule. So 3 questions. What percentage of the students had scores between 25 and 45? There are 400 students in the year group. How many got a score greater than 65? And students who got less than 35 marks had to resit in the summer. How many students are scheduled to resit? So let's take a look at this question in its entirety. Now, my advice here before we do that is that you try this question yourself and then watch the video or skip ahead and see if you got it right. Okay, so let's take a look at example 2. So in this one, it said the principal normally distributed the school's maths grades and found that 68% of students had a score between 45 and 65 points. So I'm going to sketch the curve again. And I'm going to say, well, hold on, what's 68% again? So 68% is my first empirical rule. It means it's that 1 standard deviation away from each other. So this part here is my 68%. And that's going to help me out because he tells me that it's the student body scored between 45 and 65. Hey, so I think I can figure out the mean and standard deviation from this. So I need to find the difference between 65 and 45. So I grab my calculator and the difference is 20. And then there's 2 regions, so I'm going to divide by 2. So it's going up 10. So it goes 45, 55, 65. Or you could just find the middle number of those 2. Now, once you've done that, you have your mean. And you know the difference is 10 each time. So you can finish off this little question here, going back and marking in all the different scores. So part A just asked what was the mean and standard deviation. So the mean here was the middle number, 55. And the standard deviation is how much they differ by, 10. Okay, part B then, it said to use the empirical rules to solve the following. So what percentage of the students had scores between 25 and 45? So I'm going to do what I've done so far in all these questions is I'm going to separate these regions up and just mark in what the percentages are. So this is 34 and 34, 13.5 and 13.5. And you'll find if you do this every time, it's just going to commit to your long-term memory. And this won't be a stressor question then. So now that I've marked it in, between 25 and 45. So that would be these two regions together. So 25 to 45 would be adding, I'll just write it here, 2.35 plus 13.5. So I go 2.35 plus 13.5. So 15.85% of the student body scored between 25 and 45. Part B then, part 2. There are 400 students in the year group. How many got a score greater than 65? So greater than 65 is these three regions here. So I'm going to say score greater than 65 would be 13.5 plus 2.35 plus 0.15. So adding those together is 16%. So 16% of the students got a score greater than 65. But just be careful. He asked, there are 400 students in the year group, so how many of them? So you need to find 16% of 400. So I'm going to do 400. You can do it by 16 over 100, or you can do it by 0.16 to get you the value. And that value is 64. So 64 students scored more than 65 points. And the final part, part 3. Students who got less than 35 marks, had to resit in the summer. How many students are scheduled to resit? So very similar. So we're looking for a score this time that was less than 35. So that would be these two regions on the far left here, 0.15 plus 2.35. So adding them together, 0.15 plus 2.35, we get it to be 2.5%. So 2.5% of students had to resit. There are 400 students, so I'm going to do 400 to turn anything from a percentage to a decimal, just divide it by 100. So there we go. So I'm going to do 400 by this number here, 0.025. And it turns out 10 students have to come back in the summer to resit. Okay, now let's take one last look at a Leaving Cert example of an ordinary level question. Okay, so just taking a look, we're taking a look at 2020 question 3B. So B part 1. An aptitude test was taken by 6,500 candidates. The test scores were normally distributed. Awesome. The mean score was 480 and the standard deviation was 90. On the distribution shown below, the shaded area candidate represents all candidates who were within one standard deviation of the mean. Write down the value of A and the value of B in the boxes below. Then the second part, use the empirical rule, there's our key word, to estimate the number of candidates in the shaded region. So have a go at this question first yourselves, and then have a look at the solution here with me. Okay, so taking a look at this 2020 Leaving Cert B question. So he'd given us a curve, I'll just sketch it nice and quick here, and he'd told us the mean was 480, and he told us the standard deviation was 90, and he wanted us to label A and B. So in the B part 1 here, question 3, 2020, all we have to do is add 90 to 480, so grab our calculator if we need to, add 90, so the B was 570, and go back 90 from 480, the A was 390. That's pretty nice going for a B part 1 part. So that's it. All we have to do is add 90 forward and back. We're good to go. The second part then said use the empirical rule to estimate the number of candidates in the shaded region. So the shaded region was this region here. And he told us that this was one standard deviation away from the mean. So we know that these two regions together is 68%. And he told us there were 6,500 candidates. So I'm going to find 68% of that. So I times it by 0.68, grab my calculator, plug it in, and we got it to be 4,420 candidates scored. It was the number of candidates in that shaded region. And that's it for the 2020 question 3, 1 and 2, B1 and 2. Let's have another look at a Leaving Cert question. Okay, so taking a look at the 2021 paper here, in paper 2, sorry, 2021, question 5a was just a short little bit on using the normal distribution. So the heights of a given population are normally distributed, so you're always looking for those keywords there. And 95% of the population falls from here to here. So this represents 95%. So just be careful to read the question nice and carefully. Using the empirical rule, there we go, find the mean and the standard deviation of the distribution of heights in the population. So again, have a go at this yourself and then have a look through the solution and see if you're getting it right. Okay, so let's take a look at solving this 2021 question 5a part. So he's given us a curve and he's marked in 2 places on it. He's told us 178.7 and then somewhere over here, over to this side, he said 147.9. And the key thing for us to realize was that he was saying that this region from here to here represented 95%. And 95% means it is 2 standard deviations away from the mean. So if they take this to be our mean here in the center, where it always is, then this is 2 away. So we know now the distance between here and here is basically 4 segments. If I just break that up there nicely. So what I'm going to do is I'm going to find the difference between 178.7 minus 147.9. So grab my calculator and plug that in. So 178.7 minus 147.9 gives me 30.8. So 30.8 represents this whole 4 regions. So I'm going to divide that by 4. So why am I dividing that by 4? Because it's 1, 2, 3, 4 regions. So I get that if I add 7.7 to each region, dink, 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 I should get from 147 up to here. So we'll just check it before we start plugging in answers. So I'm going to start at 147.9 and I'm going to add 7.7 to it. And I get this to here to be 155.6. Add another 7.7, 163.3. Add another 7.7, 171, and then add one more 7.7, and sure enough, I get to that number, so I've done it correctly. And now I've got all my answers I need. The mean here is the center number, 163.3 centimeters, and my standard deviation is the 7.7 centimeters. And that answers us for 2021 question 5a. Let's have a look at another one. Okay, so taking a look at 2022 question 4b of ordinary level maths paper 2. So here we're given a large group of people took a reading test. Their scores were normally distributed, there's those keywords, with a mean of 100 and a standard deviation of 20. And he's given you the curve here and he's put the mean in for you. Use the empirical rule to answer the following questions. What percentage of people had scores between 80 and 120? The top 2.5% scores were given the grade exceptional. What was the least score that was needed to get this grade? So let's have a go at this part ourselves. Give it a go and then have a look at solution and see how you get on. Okay, so we're taking a look at the 2022 question 5 part B. And what he's done is he's told you that they did a reading test and he gave you a curve. Now I'm just going to show this here just to stress this. In the curve, he showed it like this. So he said that was 1 standard deviation, 2, 3, and then he showed kind of it here. But you need to realize that even if he shows it like it looks like it touches the curve, there is a region out here, right? So just ignore whatever he's got. It's always going to be the same idea. So what I mean by that is that there is that little 0.15 out here that we're just not showing, okay? Cool. So what do we have to do? First off, he tells us it's normally distributed. He tells us the mean is 100 and the standard deviation is 20. So let's just plug in our numbers. So 3 standard deviations to the right and 3 to the left. And then I'm going to put in my percentages as well. So 34, 13.5, 2.35, 0.15, and the same on the left. 34, 13.5, 2.35, and then this bit on the tail end, 0.15. So just be careful of that. That's how he kind of throws people a bit because people just think it ends there, right? But there is those regions out there. So B part 1 asked, what percentage of people had a score between 80 and 120? Well, that's very nice. Score between 80 and 120 is going to be our first standard deviation either direction. So it's just 68%. So that is 68%. The second part there said the top 2.5% were given a grade of exceptional. What was the least score that was needed to get this grade? So the top 2.5 is the 2.35 plus 0.15. So if you add those two regions together, you will end up getting 2.5%. So effectively, what score do I need to get? The least score I need to get into this region is the 140. So the answer is a score of 140. And that's it for 2022 question 5B of paper 2. That should hopefully tie you up nicely for all the things that you need to know doing this question. So guys, just to reiterate and to kind of what's the key skills you need to take away here. So you need to know these three numbers, okay, in particular, or what I recommend as well is learning this graph or this, sorry, graph, learning this curve and learning each percentage region. You see the questions just fall out then and they're super easy. So if you've got this learned down, you should hopefully find these questions fairly manageable. And best of luck with your studies. Leave a comment or click like, subscribe and all that jazz. And all the best.
The force is strong with this one. Seriously, your camera's way too close. Personal space. Personal space.